All right, so today, you all took obviously trigonometry last year, either in Algebra 2 trig or trig as a semester class, right? So when we talk about trig, what is trig? It's a measurement of what? When did you use trigs, huh? Triangles, yeah, it's just a measurement of triangles. And you dealt with trig when it came to right triangles, you dealt with it when it was, did you guys do law of sines, law of cosines? When they weren't right triangles and you still had to find angle or side measures? Remember that? Yeah, no, okay. Now let's talk about before we get into that, because we are gonna have to do like the unit circle, all of that fun stuff where we make those triangles. And I know if you had trig as a semester class, you had to memorize the unit circle. Is that true? And you guys had like tests and things like that on it? Yeah, okay. An angle is just rotating a ray half line about its endpoint. Okay, so angle is formed by two rays, right? You have an initial side and you have a terminal side. Okay, the initial side is your starting position, not point, I should say position of the ray, and then the terminal side is the position after you rotate it, after the rotation. Okay, so we start with this initial, and then as we rotate it, we end up with that terminal forming this angle here, which we will usually label it as theta. Okay, you do it on, obviously on a coordinate plane where you start here at the line, and then you can rotate to and finding angles in like pi over 2 radians, pi over 6 radians, 13 pi over 2, whatever it is, okay? Does anyone know how many radians it is around a circle? Or a full circle makes how many radians? We're going to get to that, but if you don't, I was just seeing if you know. Anyone? We do know a whole circle is how many degrees? 360 degrees. Half of circle is 180. 180 degrees is actually pi, is equal to pi radians. So what would 360 be then? 2 pi radians, okay? All right, a vertex is obviously the end point of it. The standard position of the angle is the angle. Positive angles are formed with counterclockwise rotation. Which way is counterclockwise? This way, right? That might be forward to you guys, right? Yeah, all right. And then negative angles is clockwise. You guys at home can't see me using my fingers, but I was going and it was backwards to them. All right. So positive angle, counterclockwise, negative angles, clockwise. So going left is counterclockwise, going right is clockwise. Okay. We're going to label our angles with Greek letters. We have the alpha, right? We have beta, and then we have theta. Okay, so we will be labeling with these Greek letters, mostly theta though. Okay, but you can see other ones in that sense. Okay. All right, so let's go ahead and talk about radians first, and then we're going to do degrees. Okay, so one way, again, is to measure is using radians. Instead of like 180 degrees, we'll say pi radians. Okay, the measure of the angle is the amount of rotation from the initial side to the terminal side. Does anyone remember what the central angle of a circle is? So like if I have a circle, what is my central angle? This is pulling back from geometry now. No, remember it's from the center. Your central angle is formed by 2 radii. Okay, so it's an angle whose vertex is the center of my circle. And when you remember that central angle, you could find arc length. Do you remember that? Find an arc length, the length of it from here to here, or you could find the area of a sector, right? The area within this circle. You guys remember doing that? Whether you remember how to do it, but you remember doing it, right? Okay. All right. So 1 radian, okay, is the measure of the central angle theta that intersects the arc S equal to the length of the radius R of the circle. Okay. It is formed by taking the S divided by R. Okay. And again, S is what? The arc equal the arc length equal, okay, so it's the arc length divided by the radius. Okay. And theta is always measured in radians. Okay. All right, so going from here, here's just a circle, unicircle. We have 1 radian, 2 radians, 3 radians, and so on, which we'll get into that more later. Okay. How do we find the circumference of a circle? Circumference is the same thing as like the distance around our circle, right? Like perimeter. How do we find the circumference of my circle? It is 2 pi r, yeah. It is 2 pi r units. So it follows that the central angle of 1 full revolution. 1 full just means around the circle 1 full time. Okay, so 360 degrees, right? Okay, corresponds to the arc length of S equals 2 pi r, which should make sense, right? If I go from the circle and I go all the way around it, isn't that the distance around my entire circle, which is my circumference? Okay, so 1 time around would be 2 pi r. If I only go half of the circle, we know that's 180 degrees, right? So that would be just pi radians, because 1 time around, isn't that 2 pi? Yeah. So then half of it would only be pi. Okay. 1/6 of a revolution is pi over 3 radians. And then 1/4 of it would be pi over 2 radians, right? Because you start with 1 revolution is 2 pi. And then if I divide it by a half, would be divided by 2. Divided by a 6 would be pi over 3. 4 would be 1/4, right? Pi over 2. 1/4. Okay. All right. So find the coterminal angle for the positive angle of 13 pi over 6. Okay. Well, let's think about this. 13 pi over 6. Isn't that the same thing as 1 whole and 1 pi over 6? Is that the same? Isn't 13 over the 6 the same thing as 1 and 1 pi over 6? 1 and 1/6, huh? Or 2, sorry, 2. Sorry, 2 and 1/6. I don't know why I said 1, sorry. Okay. But if we think about that, okay, we know 13 pi over 6, really, we're going around the circle, right? We're going around the circle, and then we're adding in what? Just 1/6 of that, correct? So if I want to actually find the coterminal of 13 pi over 6, couldn't I just subtract off 2 pi? Because don't I go around that circle 1 entire time, actually 2 entire times? And then I'm left with what? 1 pi over 6, or pi over 6. So if we're thinking about this, okay, 13 pi over the 6 is actually going to be the exact same as pi over 6. Wouldn't that make sense? Because if I go around once, right, what would that be? 2 pi, right? And then I have to add in another what? 1/6 to get to 13 over 6, right? All right, find the coterminal angle for the negative angle of -2 pi over 3. So now we're going in the negative angle, right? Okay. So we're going clockwise to negative 2 pi over 3, okay? So now we need to find the positive angle that would get us to this negative 2 pi over 3, right? So instead of subtracting 2 pi over 6, I'm going to add it. Yeah, so I'm going to add 2 pi plus this negative 2 pi over 3. Or I could put this plus 2 pi. It doesn't matter the order you do. So negative 2 pi over 6 is going to be equal to what? What do you guys think? 4 pi over 3. Yep. So if I would go counterclockwise, that would be to 4 pi over 3. That would be the same thing as a negative 2 pi over 3. Okay. So if we're negative angle, we're going to add 2 pi, right? And if we are a positive angle, we're going to subtract 2 pi. Because we're looking at what is going to be the same, okay, between that. So I could have looked at a positive 4 pi over 3, or I could do a negative 2 pi over 3 is going to be the same measurement, okay, depending on which way you go around. Okay. All right. Find the complement of 2 pi over 5. What does complement mean? Yeah, the two angles together add to be 90 degrees, right? But we're in radians. So does anyone know what 90 degrees is in radians? Close, let's think. If we know 360 is 2 pi, 180 is what? 1 pi. So what would 90 degrees be? A half pi, or pi over 2, right? Does that make sense? Because each time you're dividing by 2, okay? So we know 2 pi over 5 plus what would have to equal 90 degrees, right? Yes? Okay, so plus what would have to equal pi over 2, right? So what would I do to these two radians to get to my actual complement? Anna, you said it actually earlier. Subtract them, yep. So I'm going to take pi over 2 and subtract it from 2 pi over 5. The complement means the two angles add to be 90 degrees. Okay, so this is our 90 minus my angle in radians. So what would we get here? Pi over 10. Yeah. And how did you do that? You had to find our common denominator. Okay. All right, supplement. What does supplement mean? It's 180 degrees, right? So the two angles add need to be 180. Well, what is 180 in radians? It's pi. So I'm going to take pi and subtract off what? 2 pi over 5. And what do we get? Hmm? 3 pi over 5. They're both going to be positive, won't they? And you were on a roll, and then no, just use it. Okay. Any questions with complements, supplements? Finding your angles. If it's positive, subtract 2 pi. If it's negative, add 2 pi to it. Okay. Yes, ma'am. Are you sure? Oh, did you find the wrong common denominator? Oh, okay. That would happen. All right, degrees. Degrees. Another way, obviously, is in degrees, which I think you guys are so used to doing everything in degrees, right? The 180, 90, all of that, which is nice. The radians are new. Once we get into that, that's pretty much everything we're going to do is in radians. Okay. Do you remember how to convert degrees to radians? No? Okay. We multiply the degrees by pi radians over 180 degrees. Why do we divide by 180? Because 180 degrees is equal to pi, right? 1 pi. You could do 2 pi over what though? 360. Okay, so either way. To convert radians to degrees, we multiply 180 degrees over pi radians. So it just kind of flips. If we have radians, okay, if we have radians, we actually divide by the pi. Multiply by 180, divide by the pi. If we have degrees, we multiply by pi, divide by the degrees, okay? So the relationship is pi radians is equal to 180 degrees, which we already talked about this earlier, okay? Which I really think we should do degrees before radians. All right, 135 degrees. So we have the degrees. So we're going to take 135 and multiply it by pi radians over 180 degrees. And the reason why 180 is in the bottom is so our degrees can cancel off and we're left with the radians, right? So what's 135 times pi divided by 180? We always, always, always leave these as fractions, not as decimals, okay? So what can go into 135 and 180? You guys have calculators, so you could use them, but, or if you guys have the ABC button or the, because I see your calculator, if you put the fraction, put 135 over 180 and it will simplify it for you. So what did you guys get? 3/4, right? So it'd be 3 pi over 4 radians. So yeah, use your fraction key. Use your fraction key. Fraction key. Do you have a fraction key, don't you? Yeah. So the ABC on some of those, Alex, I can't see your calculator, Ryan, but you guys should. Yeah, you have the N over D, I think, in your calculators, right? Just do that. Okay. All right, B, 540 degrees. So I'm going to take 540 degrees times pi over 180 degrees. So 540 over 180 simplifies to what? 3. So it's just 3 pi radians. All right. Convert radians to degrees. Okay. So in this one, instead of dividing by 180, we are multiplying by 180. So we're going to times 180 over pi. So what happens to these pi's? They cancel. So then what's negative 180 divided by 2? Negative 90. So negative 90 degrees, which we should have known. Didn't we already know pi over 2 was 90? So negative 90 in that sense. All right. 2 radians. Not 2 pi, but 2 radians. Okay, so that's going to change it a little bit, isn't it? We still have our radians, so we're going to multiply by 180 and divide it by pi radians, right? So the radians cancel. So now what's 2 times 180? 360. Now, do we cancel out my pi's? No, so we're going to leave pi there. So we actually have 360 degrees over pi, which let's go ahead and simplify that. Because we're in degrees, do you think we want pi? No. So you can go ahead and round to 2 decimal places. So round to the hundredths. So what degree is 360 divided by pi? And you guys should have a pi key on your calculators. Make sure you use the pi key and not the 3.14. Okay. So what did you guys get? Hundredths? 5.9 degrees? Huh? Oh, okay. Okay. All right, and there you go. Okay. All right, so now we're actually going to find the arc length of it, the distance before. Back in geometry, when you guys talked about arc length and that, you probably left it straight in degrees, right? We're going to leave it in radians now, okay? So normally with arc length, okay, you took the perimeter times the part of the circle you were using, okay? Now, for this one, okay, with us leaving it in radians, our arc length is the radians times theta. And theta is my central angle in radians, right? So the R is my radius and the central angle theta, which is in radians. Okay, so it needs to be in radians in that sense, okay? Which it does tell you if you keep reading, but all right. All right, so a circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle of 240 degrees, okay? So now we are using the formula, the arc length equals my radius times theta, okay? Theta is my, again, angle, central angle, which is 240 degrees, but we need to turn it to radians. So how do we turn 240 degrees into radians? So do we multiply by 180 and divide by pi, or do we multiply by pi and divide by 180? Okay, so remember, we want to cancel the degrees out. So if the degrees is in the numerator, to cancel it, it has to go to the denominator. So we multiply by pi radians over 180. Okay. So what is 240 divided by 180 as a fraction? So this simplifies to 4 pi over 3. So my theta is 4 pi over 3 radians. Okay. So now let's go ahead and find my arc length now. So my arc length is equal to my radius. And what's my radius? What is my radius? 4 inches times theta in radians. And what's my theta in radians? 4 pi over 3. So what's 4 times 4 pi over 3? So 4 times 4 is 16 pi over 3. So exact answer, my arc length is 16 pi over 3 inches. Okay. So the length from here to here exactly is 16 pi over 3. What is it rounded to the 100th? What is that rounded to the 100th? So So the distance around that is 16.76 inches. Okay. That makes sense to you guys? Now, would you be able to find the other part? Could anyone find the length from here to here? What do you think? What's my central angle? What measurement is my central angle? The 240 is for my orange. What would be the green? 120 degrees. Yeah. Huh? So could we take 120 and turn it into radians? Yep. And then times it by the 4? Yeah. What did you guys get for your radian? Can you do it real quick? Without using a calculator. What do you think? What would 120? We know 240 is 4 pi over 3. What would 120 pi be? It'd be 2/3. Why? Okay, well, we know a whole circle is how many degrees? Well, it'll be 2 pi, right? 360 degrees, which is 2 pi. And if 240 is 4 pi over 3, what would get us to 2 pi? Wouldn't that be 2 pi over 3? Yes, so good job. Yep. All right, and then could you multiply by 4 from there? Yeah. All right. All right, linear and angular speeds, okay? The linear speed is our velocity, okay? Which is my arc length divided by my time. So arc length divided by time. And how do we find arc length? Obviously, they mark it as S over T, but how do we find my arc length? We just did it. The radius times my theta divided by time, right? Okay. The angular speed, okay, which is W, is our central angle divided by time. Okay, so it's just theta divided by time. So it does not get multiplied by the radius in that sense. Okay, so we have a linear speed and an angular speed. Okay, and again, I will let you guys, I'll give you these formulas on the test and things like that, your quiz. Obviously, your quiz, you'll be at home, so you'll have that. But all right, the second hand of a clock is 10.2 centimeters long, as shown below. Okay. Find the linear speed of the tip of the second hand as it passes around the clock face. Okay. So as it passes around the clock. Okay. So if we're passing around, the second hand's passing around the clock the entire time. Okay. It's going how many degrees? 360, right? It's going 360 degrees. So we know my actual angle is 360 degrees, which is what in radians? 2 pi. So 2 pi radians. Okay. All right, so I was just kind of talking through there a little bit. Okay. Now we're finding linear speed. So we know it's going to be my arc length, so radius times theta divided by my time. Okay. So what is my radius? How big is my second hand? 10.2 times my theta. And my theta is my degree, my central angle in radians. And what is my central angle in radians? 2 pi divided by now my time. If the second hand goes around, right? The second hand goes around, that takes up how much time? A second hand going around takes up how much time? Huh? A minute, which is how many seconds? 60 seconds. So my time is 1 minute, which is equal to 60 seconds. Now, Why am I going to use 60 seconds over 1 minute? More, but it's actually because it's talking about the second hand. So we're going to turn it into seconds. Okay. All right. So divided by 60. So what do we get for my linear speed? Is approximately what? .07. What now? Centimeters per what? Per second, right? Why? Because 10.2 is in centimeters, right? And the 60 was our seconds, right? So isn't this centimeters per second? Could anyone tell me what my linear speed was? As Ryan said, what if it was centimeters per minute? Anyone tell me what it is for centimeters per minute? 107. Is it? 10 point, no, what's 10.2 times 2 pi? What is it? I don't have my calculator. So. 0.09. Okay, why? Because you're taking 10.2 times 2 pi. That's why I don't think it was the same. Because you're dividing by 1 in that sense, right? Yeah. I'm like, I don't know. Since you said minutes, that's why I asked the question. So just make sure you label it. Obviously, if you did it in seconds, centimeters per second. If you did it in minutes, make sure it's centimeters per minute. Okay. Now we should have done seconds just because it was talking about the second thing. Okay. All right, example 7. The blades of a wind turbine are 116 feet long. And there's a picture in your book. I didn't copy and paste it to this one because I didn't want to take up too much room. The propeller rotates at 15 revolutions per minute. Okay. So revolutions per minute. So we know since we're doing it per minute, we're going to use our time as what? A minute, right? Our time is going to be 1 minute here. Now, 15 revolutions. We know 1 revolution is how many pi? 2 pi, right? 1 time around, isn't that 2 pi? So what would 15 revolutions be? 30 pi. Why? You would have to multiply by 15 because 1 times 2 pi, 2 times 4 pi, 3 times 6 pi, and so on. So we know it's 30 pi, okay? So find the angular speed of the propeller in radians per minute, okay, per minute. So remember, our angular speed is our central angle divided by my time. Well, what is my central angle? What is my theta? 30 pi, because we're going around how many times? 15 times, right? Divided by my time, and my time is per minute. So 1 revolution is 1 minute, right? So what is my angular speed? 30 pi radians per what? Per minute. So we know that turbine is going around 15 times in 1 minute. So 30 pi per minute. Okay. Now, find the linear speed of the tips of the blade. Okay. So linear speed, remember, is my arc length. And my arc length is the radius times theta divided by my time. So what is my radius? How long is my wind turbine, the blade? 116. What is my theta? What's my central angle? 30 pi, yep. Divided by, what's my time again? One minute. So we get, so we get 3,480 pi feet per minute. A minute. Now, let's go ahead and round both of these. Go ahead and round both of these. So what is 30 pi radians per minute? What was that? It was 30 times pi. Hit the double arrows at the end. Huh? There you go, 94.25 radians per minute. Yeah, if that ever happens on your calculator, just hit those double arrows. Another way is if you go to the, hit the math button up top and change the math font. But I like the double arrows, it'll do it every time for you. Okay. And then what about 3,480 pi? So there is our angular speed and our linear speed from it. As long as you have the formulas, I think it makes it pretty easy for you guys. All right, and then our last one, areas of the sector. Okay. Now, again, you learned how to do this. Area was always, remember, you take the area of a whole circle, which is pi r squared, and then you would times it by the portion of the circle you're looking for. Now, again, we're looking at it in radian sense from geometry. Okay, so the sector of a circle is the region bounded. So it's not the whole circle, it's just a certain part of the circle. Okay. Now, how we find that is actually 1/2 r squared times theta. So 1/2 of your radius squared times theta, right, in radians. Okay, so we always need to make sure that's in radians. Okay, that's an ugly theta. Right, before you guys always did it in degrees. Okay, a sprinkler on a golf course fairway sprays water over a distance of 70 feet and rotates through an angle of 120. Find the area of the fairway watered by the sprinkler. So we're finding just this area of it, okay? So the nice thing, if we have our formula, A equals 1/2 radius squared times theta. We already know our radius, right? What is my radius? 70 squared. Now we just have to figure out our theta, right? What is, and how do we find theta again? We know our angle, right? It's 120 degrees, but we need to turn it to what? Radians. And how do we turn degrees to radians? We multiply by pi divided by 180 degrees, okay? Make sure if you have degrees, you always want to divide by degrees. If you have radians, you always divide by radians, okay? All right, so what is 120 degrees divided by 180 degrees? 2/3, so we have 2 pi over 3. So we know our theta is 2 pi over 3. All right, so what's 70 squared? What's 7 times 7? 49, and add 2 zeros. The 2's will cancel, won't they? So then we have 44,900 pi over 3, which is approximately what? Point 27 feet squared. There you go. And that is the area that the sprinkler covers there. That's it. Any questions? Tired? Any questions for you guys at home?